Okay, so let me see if I control here. All right. So yeah, this is our semester fall. This is the first learning outcome. You don't have to worry about this part. This is our course, Principle of Networking, ITGN235. Okay, so the outcomes of this lecture by the end of this course, actually, not just the lecture, to describe the network concepts, including the layers. We have two, let's say, families of layers. We have OSI layers, open source interface or internetwork, and we have the TCP/IP layers. So we have to describe both protocols, ISO and TCP/IP. Explain the concepts of various hardware network devices. We have switches, we have routers, we have the PCs, the computers, and there are many. So you need to know the details about each device, and don't be surprised. During the exam, you will be asked to write about it, like describe the switch and how it operates, or describe the router and how it operates. Apply IP addressing techniques to create local area networks, LAN. We're going to talk about it in a few minutes. So basically, each device has an address. We have two types of addressing. There is the physical address that you can say the device is in location, let's say in room A over the shelf. Or there is the logical one where you can say that, okay, this is the device and has an IP address that is, let's say, made of several numbers. There are regulations for that number, and most of our work will be dealing with IP addresses. The last part, and this is what we're going to do in our class activities or labs, illustrate network scenarios using packet tracer simulator software. And this is what we're going to do in the second lecture today, lecture 2. So today we're going to work on downloading the software and installing it. Many of you probably have Mac devices, Windows devices. It doesn't matter. The software is the same. It's comparable for both. And as long as you download the proper version, you should be fine. So those are the outcomes of the course. Okay, so in this chapter, we're going to talk about networks in general and some devices. So networks, what is a network? A network basically that anything that connects between two devices, including these devices. So in our case here, the most, let's say, global or famous network is the internet. And we have two devices connected to the internet. So this is the client or the user that has a PC computer or a desktop or a laptop. And there is a server that has a lot of information. So what happens, usually the device will send a message over the network or the internet will deliver it to the server. The server will then respond through the network to the user. So this is how the communication works. And nowadays, if you want to be part of the global community, you have to be connected with the internet. Right now, for example, we are, let's say, delivering the content over the internet. And you can use any kind of device you think of. You can use your computer, tablet, a smartphone, and they all have to be connected to the network, whether it was with the Wi-Fi or with the cellular data or the phone data. Okay, so here is a more, let's say, advanced chart or figure on how networks is connected. So assume that here is the internet, and here there's a company or some certain entity here. And everything could be connected or should be connected to the internet with a router. And the router job is to provide and distribute, give some smart routing to the messages to know where the message should go and should not go. The firewall here is for protection. Basically, sometimes harmful messages might come off the internet in the form of viruses, malwares, and stuff. The firewall here, its main job is to protect your machine, your devices from, let's say, being harmed by these viruses. All right, then after the message passes the firewall, now it will go to the switches. Now the switch job is to define where the message should go. So this one gives some intelligent routing. We're going to talk about it in a few minutes. The switch let's say it gives, like it tells where the direction should go, where the message should go. Notice there are many machines or many devices connected to the switch. For example, here we have servers. There's the file server, database server, web server. The switch decides where the message should go based on the contents of that message. There are some headers that are appended to the message. They basically tell where the message should go. Another switch here is connected to the users. Another switch to another Wi-Fi access point, which is in the form that we know commercially that this is a router, but it's different from this router here. So this is from, let's say, the commercial router. Actually, it's not a router. We call it access point. The router itself is the one that is connected to the main internet or to the big internet. So this is an example of how a network look like. Pretty much like here in the University of Dubai, we have pretty much the same thing. We have servers for our files, our folders, our contents. We have a switch that connects to the PCs through cables. And we have this one, the access point that connects to the Wi-Fi devices, personal assistant unit, PDA, a laptop, a phone, and so on. Another chart here, this is how the desktop is connected through the Ethernet. You probably heard of it. And actually, we're going to dedicate a lecture for the Ethernet. And the Ethernet, in fact, is a switch. And this one will give you access to the internet. And you notice here, this port here, that's the Ethernet port, and should be attached with an RJ45 cable. Also, we have a lecture on the physical devices or the physical media about the different forms of cables. There we have coaxial cables, we have copper wire cables, fiber optics, and we have the RJ45. And this is the most common one, basically because it's cheap and it does the job. If you want faster, then you go to the fiber optics one, which is going to be more expensive when compared to the RJ45. So this is one way to connect to the internet through cables, and there is the other one through Wi-Fi. And by the way, did I start recording? I think I did. Does it show that it is recording? Anybody? Are you guys with me? Okay, it is recording, right? Let me double check. Okay, yeah, it is recording, yeah. Okay, so let's keep going. Okay, so basically what is the internet? It's a global computer network. It has every machine you think of, they are connected to the internet. You can have many servers like Skype server, eBay, the online purchasing, pretty much like Amazon, the news network, CNN, and we have YouTube. And we have the users here that are all connected to the internet. So it provides a variety of information and communication facilities. Also, we have services like email, search engines. It consists of interconnected networks using standardized protocols. Yeah, we'll talk about the protocols later. They are the OSI and TCP/IP. That's going to be the topic probably on the 3rd or 4th week. All right. Now let's talk about network devices. Basically, you cannot connect to the internet without having the proper devices. You need a device that gives you access to the internet, and you need a device that will allow you to receive a message or a signal or an internet signal. So equipment that connects directly to the network, they are known as the devices. And there are two types. There are the end user devices, basically like a laptop or a phone or a machine. So this one is at the user side, at the end user side. And there's the network devices, and in another name, intermediary devices. Intermediary, they are in between. They are, let's say, the ones that grants the message, let's say, to move from the server side into the user side. And by the way, here, the end user doesn't have to be just users. It could be a server also, the one that provides the network. Here, just the connections that helps the message to go from point A to point B. So those are the two main families or classifications of devices, end user devices and network devices. So the end users include computers, printers, scanners, and many others, phones, tablets, and so on. The network devices, they are the devices that connect to the end user devices, like a router, a switch, a hub. I'm going to talk about each component of them individually. So the end devices, they are basically the ones that either provides a message or gives a message, and one that receives a message. So an end device is either the source or the destination. The source, like a server, for example. A destination, a laptop, for example. And here is a chart or diagram shows. So this one here is an end user, and here is also an end user. Here, that's the network or intermediary. And that's why they call it intermediary. They are in between both end user devices. Examples, desktop, a pretty much example or a question that you will be facing in the exam. One of these devices is not a network device, or one of these devices is not an end user device. Remember, we have two classifications, intermediary or network devices, and you have the end user devices. So a typical multiple choice questions, I will give you, okay, one of these devices is not an end user device, and you should know from the selection which one is the right answer. So end users, they are easy: desktop, laptop, printer, the IP phone, wireless tablet, telepresence endpoint. Now, intermediary devices or network devices, they connect the individual end devices to the network. So they can connect multiple individual networks to form an internetwork, pretty much like in this one here. Here are the intermediary. We have all routers. And by the way, in future, we should know that this device is called a router. And in fact, all of our labs, probably at least 6 of them, will have routers in the networks. So their job is to connect multiple devices to allow the message to go from end users. So these intermediary devices provide connectivity and ensure the data flows across the network. Examples, so this is the wireless router, basically because of the antennas, and this is the generic router. We have the switch, multi-layer switch, and firewall appliance. Again, a typical example, one of these devices is not an end user device or is not a network device. So you have the selection there, and I have the freedom to, let's say, pick the choices that I can put in the question. So keep that in mind. Okay, now network devices, basically when we draw diagrams or where we draw networks, each device has its own icon or own shape that looks in paper. Yeah, basically, let's say, for example, this is the router. But the router physically does not look like this, but this is how it looked like in the Cisco packet tracer or in the network diagram. So when some people draw network diagrams, and that's what we're gonna do in our lab, when we draw network diagrams, these are the symbols we're gonna mainly use. So there's a device called repeater. There is the bridge. There is the hub. We have 2 forms of hubs. They're kind of the same. I think it just this one supports 10 channels and this one 100 channels. There is the switch or workgroup switch, router, and there is a hub, and there is a network cloud. Most of our work will be dealing with this guy, with the router, as a network device. We did not talk about machines or desktop machines. I think those are for mentioning. We're going to talk about them, but we will not use them in our labs. So the first device is the repeater. From its name, repeater, it repeats the message. It amplifies the message. So the repeater is a network device used to regenerate a signal. Usually, like, signals will go past, let's say, hundreds of meters, and the signal will, let's say, start to attenuate or drop. The strength of the signal will become smaller as the distance grows. So to make sure that the signal is not lost, we will add an intermediate device that will amplify that signal in a way that it will receive, let's say, be sent to the destination without loss of data. So the main job of the repeater is to regenerate a signal, or we can say amplify the signal. So repeaters regenerate analog or digital signals distorted by transmission loss due to the attenuation. And the reason for that is the distance. That's the main thing. As the distance grows, the signal will become weaker. For example, voice. Let's say two persons are sitting next to each other when they can talk normally, but if they are far away, someone has to make his sound louder in order for the message to reach the destination. If he speaks with the same amount of, let's say, or the same volume, his message probably will not be delivered to the destination. Now, a good or an important point here, the router does not perform intelligent routing, or the repeater, sorry. The repeater does not perform intelligent routing. What does it mean is that it does not show that, okay, I'm sending from this message here, and the router here will decide where should it go. This is the job of the switch and the router. The repeater will not do intelligent routing. It has no idea about where the signal is going. The main job is just to amplify the signal. It has no idea where the destination is or how to distribute the message. So keep that in mind. The repeater does not perform any intelligent routing. A hub is a device that instead of sending each signal in an individual channel, group many signals together and send them in one single channel. So it concentrates the connections. This is the main job for the hub. In other words, they take a group of hosts and allow the network to see them as a single unit. Pretty much like this example here. So we have 3 devices. They all go to this hub. And this is one form of the hubs. Remember, we have too many shapes. So this is the 100 base T hub. It doesn't matter whether it was this one or this one or this one. A hub is a hub for us, as for now. So this hub here will get all these signals, pack them all together, and send them in a single channel. Now, this is done passively without any other effect on the data transmission. What it does that these signals will not interfere with each other. There is no, let's say, some coding or technology to be there. What it does, let's say one of the examples, something we will cover later, is called time division multiplexing, that each device or end user will have a time slot that can send a signal within that time slot. So the pack will be something like this. Like this one is from device 1, 2, 3, 1, 2, 3. So assuming this axis is the time axis. So all of them, they go in the same channel, but each device sends at a different time slot. Now, active hubs not only concentrate, but they also regenerate signal. So this one, sorry for this typo, I don't know what's the reason, I will fix it. So this one has the job of the repeater. So that's what they call active hub. An active hub, it also has a repeater within it. It regenerates the signal. Passive hubs, how was the input? The output will be the same. Active will regenerate the signal or give amplification to the signal. So that's the main difference between active and passive hubs. Keep that in mind. By the way, everything's clear. Any questions? Any questions? So we have the same 8 students. No questions? I think we can keep going. By the way, once we are done with the lecture, we'll start working with the Cisco packet tracer. Today's lecture is not very long. It's more into introductory about networks. After we finish this one, we don't have to wait to the next session. We'll start working with the Cisco packet tracer. Downloading the file is not straightforward. We have to be enrolled in a certain online course that's from CCNA or Cisco. Then we can download Cisco packet tracer. But it should be easy. It's not very complicated. Okay, so we did the repeater. We did the hub. Now we're going to talk about the bridge. Now, the bridge device, it converts the network transmission formats as well as perform basic data transmission management. So management here, it talks about how the traffic should go. And also when you send a message over the network, it must follow a certain data format to, let's say, to be consistent all over the network. Bridges, as the name implies, just connection between two different networks. It's a bridge to let a certain set of messages go from point A into another point in the network. So provides connection between LANs. Let's say, for example, here we have LAN 1 and here is LAN 2. If they want to communicate among each other, each device must send his message to the hub, and the hub will then deliver the message to the next hub over a switch. Okay, so not only do bridges connect LANs, but they also perform check on the data to determine whether it should cross the bridge or not. And that's what we call intelligent routing. So it does some checking where the message should go. And that's what we mean by intelligent routing, that whether the message should cross the bridge or not. So this makes each part of the network more efficient. Yeah, basically because if all messages passes through the bridge, then we're gonna talk about bandwidth. That's, let's say, the traffic at some point will be jammed, even though there are no messages should cross. But if you do not perform that, you will lose a lot of bandwidth and the network will be not efficient. And you will lose, let's say, data or time. And this is the job of the bridge, mainly to connect between two networks. Keep that in mind. And also it determines whether the message should go or not. So there are two main jobs for the bridge: connecting LANs and determine whether a message should cross or not. And yeah, if I ask you in the exam, what part of the network makes, let's say, what network device makes the network more efficient? It is the bridge. Now we have the work group switch. It adds more intelligence to the data. Now the first level of intelligence is through the bridge, determines where the message should go or not. Now the work group switch, it adds more intelligence to the data management. Basically, let's enumerate them. This is device 1, 2, 3, 4, and this is the server, and let's call device number 5. So let's assume device 1 wants to send a message to device 4. So basically, the message will be gone there. Now, usually the switch or the work group switch, it adds two ways, depending on the destination address, because this is pretty much like the mailing. It gives information about where the destination should look like. So the network switch here will check the address for each one of them. Then based on checking that address, it will deliver the message to this device. So this is what we mean by intelligent. It determines where the message should go. Instead of sending it to all machines or all end users, it determines where the message should go. And here is an example. Let's say you send an email to your friend and you guys both work in the same company. Basically, you don't want your message to be sent to everybody in the company. You want it to be to that particular person. And this is the job of the switch. Now, switches can determine whether data should remain on LAN or not, and they can transfer the data to the connection that needs the data. And that's pretty much what I just mentioned. If you, let's say, the data should go a certain path, this is the job of the bridge. Determines where the path should go. And it adds more intelligence to the routing or to the transfer management. All right, we are almost done actually. Now we'll go to the most famous part, which is the router. Router will do all the capabilities we just mentioned. It has all the capabilities of all previous devices. It can regenerate signals, that's one, that's the job of the repeater. Concentrate multiple connections, that's the job of the hub, so this is the repeater. And this is the job of the hub. And convert data transmission formats and manage data transfers. So this one was the job of the switch. And this is the job of the, what to call it? the bridge. Or the other part, yeah, this is the bridge and the other is the switch. And this is the switch. They can also connect to the wide area network, or basically the internet, which allows them to connect LANs that are separated by great distances. And there you go, this is the router. So that's why most of our labs, in fact, in all of them, are going to use the router because it does the job for all other devices. It substitutes all other devices. Here is another example on how routers connect to the network. But here we are using the physical kind of devices. We are not using the icons or the network icons. So this is the router here. And here is we have a switch. Oh, sorry, that's another router. Here is the switch. And we have end users here. Okay, so this is just a diagram on how to connect between, let's say, different LANs or different devices. We have 4 local area networks here. Okay, and the cloud, which resembles the internet. The cloud is used diagrams to represent where the connection to the internet is. Let's say pretty much the example here. So this is LAN 1, and this is LAN 2, and here we have the router. And here is the cloud, which is the internet. Yeah, the internet usually represented by the three letters www. It also represents all the devices on the internet. So yeah, if this device want to connect to the internet, it sends the message to the switch. The switch will send it to the router, and the router will go and send it to the internet. Okay, network topologies, how the devices should be connected to each other. And that will be the topic for next lecture. Now, like this device here, this is what we call a star network. Yeah, basically how the devices are connected. This one, because it looks like a star, we call it a star network. A network topology defines the structure of the network. And there are 2 types. We have the physical topology, where the devices are actually located. One part of the topology definition is the physical, which actual layout of the wire or media. And we have the logical topology, which defines how the media is accessed by the host of sending data. All right, so we have these 2 parts, physical and logical. So this one is more into IP addressing. What is the address for each device? And here is the actual address. Like it's over the shelf, next to the fridge, whatever. That will be the topic of next week, nature of networks. Now, network media, there is a different chapter also for this one, which is like the actual devices you use for transmitting the data. We can use cables, we can use fiber optics, we can use coppers, we can use the wireless media. So all of these things we call media. Media is the means of transmission, like how data is transmitted. Communication transmits across the network on media. The media provides the channel over which the message travels from source to destination. Modern networks, and we have metal wires within cables, glass or plastic fibers within cables, that's the fiber optics, and we have the wireless. Again, we have a dedicated chapter for this topic only. And that's an example of network media. So RJ45 is part of the copper. So this one, RJ45. We have the fiber optics. We use light to send data. And here it's electricity. We have the wireless media. Basically, you don't need physical devices. You use air, and you have here the access point router, mobile phones, and there you go. These are the forms of signals here. Wireless media represented by the AC sine wave, LAN media, a single wire, and WAN media, something like this. And that's pretty much it for this lecture. Any questions so far on this topic?